our contemplations. Time for us to get going on what the new material for today is. And we're just going to talk a little bit more about standardized units. Now, to do that, I want to just take a couple of steps back and review some concepts, arithmetic concepts, from when you were younger. The first is the powers of 10. 10 squared is 10 times 10, right? That means square something means multiply it by itself. So 10 squared is 100. 10 to the fourth is 10 times 10 times 10 times 10, which is 10,000, okay? So what you notice here is that if 10 to the n is a counting number, like 10 to the first, 10 to the second, third, and so on and so forth, the answer is going to be 1 followed by that many zeros. See, 10 squared had 2 zeros. 10 to the fourth had 4 zeros. So 10 to the seventh has 7 zeros, so that'd be 10 million. 10 to the fifth has 5 zeros, so that's 100,000. 10 to the ninth is a billion because it's followed by 9 zeros. Now 10 to the negative 2 is going to be 0.01. 10 to the negative 4 is 0.0001 because a negative exponent means reciprocal. It means 1 over. So 10 to the negative 2 is 1 over 10 squared, which is 1 over 100. Now, how am I figuring out where this decimal goes? 10 to the n, if n is a negative integer, you start the decimal to the right of the 1 and then move the number of places to the left that the exponent indicates. So this is negative 2 here. So my decimal started here, move 2 places, 1, 2. Here's negative 4. Decimal starts to the right of 1, 1, 2, 3, 4. Negative 4, 4 places. Start to the right of the 1, move it 4 places. So 0.0001. Remember, if there's no number in front of a number, like is in the case with this ones, you just have as many zeros as you need. 10 to the negative fifth is 0.00001. That's a total of 5 places here. Starting on the right of the 1, you move 5 places to get to where the decimal point is there. 10 to the negative 3, start to the right of the 1, move 3 places, 0.001. And normally we put a 0 in front of that, 0.001. The only thing that matters is how many places between the decimal point and after the 1. Okay. So the next thing we want to consider is, that shouldn't say 100. That should say 10 to the 0 is 1. I don't know why that says 100. Let me correct that real quick. I can't believe it says it. Ready? Showing you how a trained professional handles an emergency situation. Take a brief commercial interruption on the other one. I still have too much stuff written in there, but we'll follow it out. 10 to the 0 equals 1. Really? No, I mean it. I'm serious. Why? Why in the world does 10 to the 0 equals 1? On the surface, that makes absolutely no sense. Well, when we divide terms with exponents in the same base, we subtract exponents. Like this. 10 to the 5th over 10 to the 3rd. 10 to the 5th would be, we talked about it before, a 1 followed by 5 zeros. 10 to the 3rd is a 1 followed by 3 zeros. Die. Cancel them all out. I get 100 over 1, which is 100 or 10 squared. So notice 5 minus 3 gives you the 2. So over here, 2 minus 2 is 0. So that's how I get 10 to the 0. But you learned early on when you were in elementary school that, look, most kids hate division when they're in elementary school. But this one thing stuck with you, and like everybody remembers this, and they all like it. What's anything divided by itself? It's 1. So on the other hand, I have 10 squared divided by 10 squared, so that has to be 1. So that is your explanation as to why 10 to the 0 is equal to 1. Now, when bases are the same, you add the exponents when you're multiplying. You subtract them when you're dividing. We just established that. When you're multiplying, you add them. So 10 to the 3rd times 10 to the 6th is 10 to the 9th. Add the 3 and the 6. 10 to the 4th times 10 to the negative 3 is equal to 10 to the 1, just add the exponents. 4 plus negative 3 is 1. So 10 squared times 10 to the third, well, 10 squared is 0, 0. 10 to the third is 0, 0, 0, right? The exponent is how many zeros there are. So I look over here, if I do it on a calculator or scratch it out by hand, 100 times 1,000 is 100,000. Notice you got 5 zeros there, right? 1, 2, 3, 4, 5. And here, 2 times 3 gives me the 5. So that's why you add exponents. And those are the examples we just did before. When bases are the same, you subtract the exponents. We went over why just a minute ago. So the next part is a brief review of the powers of 10. When you raise a power to a power, you multiply. 10 squared cubed means 10 squared times 10 squared times 10 squared. Remember, to cube something means to use it as a factor 3 times. So altogether, according to the rule, to add exponents, 2 and 2 and 2 is 2 times 3 or 6. There's no shortcuts for addition and subtraction. Absolutely none. Expand the exponents and either add or subtract. Some examples: 10 squared plus 10 to the fourth. 10 squared is 100. 10 to the fourth is 10,000. You'll get 10,100. 10 to the fifth minus 10 to the third is 100,000 minus 1,000, which is 99,000. How does this relate, by the way, to that great truth we learned before about how whenever you add or subtract anything on the face of the earth, they need to be alike? Well, remember, you can only add or subtract things that are the same kind of things, like puppy dogs and kittens. Like things must be grouped. So if I write out 10,000 plus 100, which is what 10 squared plus 10 to the fourth is, I have to line it up so that the ones are with the ones, the tens are with the tens, the hundreds are with the hundreds, and so on. That's why you have to literally add them, because if you don't do that, then you're not getting your puppy dogs with your puppy dogs, your kittens with your kittens. I'm sorry, I mean your ones with your ones, your tens with your tens, your hundreds with your hundreds. So that's why it is so important that we line those things up whenever we add or subtract. So we deal with addition and subtraction very differently than we do multiplication and division. Multiplication and division, we can just go at will, just start multiplying, dividing, do whatever you want. If the bases are the same, we add exponents if we're multiplying, and we subtract them if we're dividing. When we raise a power to a power, we multiply. All of that's clearly understood. What we don't get is when we add or subtract. To add or subtract with exponents involved, you have to get your like terms together. And in the case of numbers and arithmetic, that means lining up your ones. So you're grouping your ones with your ones, your tens with your tens, your hundreds with your hundreds, and so on and so forth. Okay. Now, the big thing that we want you to be able to do here is to know how to convert amongst things that have conversion factors. You do not need to walk around with all of these conversion factors off the top of your head. I am 58 years young. Some of these things I do walk around with off the top of my head. Most of them I do not, and some of them I kind of think I can remember most of the time. It's okay. You can always look them up if you have to. But the cool thing is that you know how to convert. And that's where we have our two methods: big to small, small to big, multiply, divide. And then we also have where we set up the cancellations so that we come out with our answer in the end. So here's the conversion factor. And if you need to look back at this, you can. What I would strongly suggest everybody does right now is that you get your cell phone out and you take a picture, or if you're looking at this on your cell phone, that you do a screenshot and you save it. And then anytime you need to do any conversions, like on our review sections or quizzes or tests, which always have review questions in them, that you just take this out and you look up the conversion factor so you can help yourself. Here are 3 examples, and they're all based on that previous with the measurements. So for instance, assuming liquid measurements, which is really all I do. We don't really do dry pints and bushels and pecks and quarts. So if I do a liquid measure, I might do pints to quarts. There's 2 pints in every quart. I could do quarts to gallons, there's 4 quarts in a gallon, and so on and so forth. So do those conversions. Have you just do the first one. I'll show you the answers to it, and then we'll do each one at a time. Okay, so assuming you're done with your stop and start, if I want to go from quarts to gallons, how many quarts are in gallons? I'm actually starting with the gallons and concluding the quarts. So what I'm doing doesn't necessarily match word order. I'm going gallons to quarts. Gallons to quarts is big to small. So I'm going to multiply. How many quarts in a gallon? That factor is 4. So 5 times 4 is 20. And the answer is that there are 20 quarts. You try the next one. Okay, so now I'm going from pints to quarts, and a quart is bigger than a pint. So I'm going from small to big, so I have to divide. The factor is 2, because there are 2 pints in every quart. 16 divided by 2 is 8. So 16 pints is 8 quarts. Next up, how many pints are in 8.5 gallons? And we can't go, well, you might be able to go directly from gallons to pints. I can't. But I can go from gallons to quarts to pints. So it's a multiple step guy. Okay, so if I go big to small, I'm going to multiply. And when I go from gallons to quarts, you can bet that I'm going to go from a big to a small. Gallons to quarts. Factor is 4. So 8.5 times 4 is 34. So I have 34 quarts here. But if I'm going to go from quarts to pints, I'm going big to small again. So I'm going to multiply. And that factor is 2, going from quarts to pints. So 34 times 2 is 68. So there are 68 quarts to pints. Okay, so that's a whole bunch of conversions and so on and so forth involving the English system. Next up, the metric system.